Hey there, it's Ashton. So for today's interactive assignment, I will be explaining why the nuclear bomb occurs and the chemistry behind it. So in a nuclear bomb, the bomb is designed so that 40% of the uranium is at the tip of the bomb and the other 60% is at the tail end. So this is the head over here and this is the tail end. The explosion causes that 60% of the uranium to shoot towards the tip as a projectile, and then this collision initiates the nuclear explosion. So let's break that down a little bit further than that. Uranium has multiple forms. Most commonly are two isotopes, which are uranium-238 and uranium-235. Uranium-238 has 126 neutrons and 92 protons. Uranium-235 has 143 neutrons and 92 protons. The U-238 is the most common form of uranium, but the U-235 is the one that is used as for an atomic bomb because of certain special characteristics that it has. Those characteristics being that the uranium-235 can withstand a chain reaction from a neutron striking it, where most of the time when a neutron hits an atom, it will absorb it and it will decay later on. Where this one, it will absorb it and immediately break into two pieces. And this produces a very, very large amount of energy, where the other form of uranium cannot do this. So when the neutron strikes the U-235, even a low energy neutron, the nucleus of the uranium will be split. Excuse my alarm. Producing two smaller atoms and a few neutrons. The neutrons will hit another uranium after they are released and cause that uranium to split, or those uranium to split. And then the neutrons produced from those collisions will collide with new uranium, and etc., and etc. This is a chain reaction that is produced. So we have uranium, a neutron hits, and it splits. And then the new neutrons hit another uranium or another group of uranium, and it just keeps building that chain reaction. So this creates a very extremely high amount of energy, hence an explosion. That is why the uranium is, and then another interesting fact is the way that the uranium is collected. And that is an important part of the bomb, because otherwise, if we have the wrong type of uranium, the explosion doesn't work because it doesn't react the same. So we need to find the U-235. So we need the setup of the bomb that I described, and then the U-235 is what we need. That's the key to make it work. And the way that the uranium is collected is very complex. The U-235 and the U-238 have nearly every physical and chemical and magnetic characteristic the same. They have the same appearance, the same boiling point, and the same magnetic strength, and so forth. And the single difference that scientists have found between the two is that the U-235 weighs a little bit less than the U-238, like 2% less than the U-238. So with this known trait, that is what leads to the separation of uranium. In order to separate them to make a nuclear bomb, they are sorted. One way of doing this, and this was the way that the first bomb was created, is by sorting them through a branching of long tubes. So with all the uranium at one end, an equal force is applied to all of them, and one of them will go faster than the other because they are different weights. And this is how you separate them. And so through a series of very long tubes, miles long, with many branches of other tubes, the two isotopes of uranium, they are racing each other neck and neck down the tunnel. And the U-235 is lighter, so it will arrive first. That is how it is collected, or it was collected that first time. And there are other techniques as well that are used, but they still use the same basis that the uranium U-235 is lighter. So it's still like using the same trait. And that is how an atomic bomb is made, at least the simple part of it, and that's the chemistry behind it. And I appreciate that lesson. It was neat watching the video, and I had dug a little bit more research on the internet, and very neat. Nuclear fission, fusion. Have a good one. Thank you.